Hi everyone, my name is Pedro Escaleira. I am a junior researcher at Instituto Telecommunications in Aveiro, Portugal, and I'm here today to present you how we are trying to get a MEC practical realization using OSM. So this is actually a follow-up presentation from one that we did last year, also on Ecosystem Day. And like on that presentation, the work that I will present today is being integrated within the project NETEDGE. So the NETEDGE project is a project in Portugal where we are trying to research some edge-related technology and how to implement and deploy a MEC environment for a very specific telco operator. So I will start this presentation by giving a quick recap of the last year's one, and then I will present the main breakthroughs we had this year in this project. So if you remember more or less the last year presentation, you may remember that we are working in this project with the very specific telco operator, which has a very specific business model. So this operator has a B2B2C model, or a business to business to consumer model. And what this means in practice is that this operator is actually an operator of other telco operators. So in an edge setting, this means that this operator is called a network service provider, or an NSP, and then it has as clients other operators which we call the CSP operators, or the communication service providers. And in turn, these are the ones which have as clients the end consumers, which in an edge environment are the ones that want to deploy MEC applications in some edge server. Therefore, in our scenario, the NSP operator wants to provide to the CSPs an edge infrastructure and also a platform where then the CSP operators can provide to their end consumers in order for them to be able to deploy their MEC applications. So in this project, we are also following the ETSI NFV-MEC reference architecture, which is this one, but we needed to make some adaptations because of our very specific business model. And therefore, we came up with this one. And the main difference of this architecture for MEC is that we are using two MANOs. So we have a main MANO, which is used by or belongs to the NSP operator, and where other CSPs can access to request access to the edge infrastructure. And when they do so, our idea is that the main MANO will launch automatically the edge MANO and the multiple MEC functional blocks. And therefore, the main MANO will also manage and orchestrate the edge MANO functional blocks and also the MEC functional blocks. Therefore, each CSP operator will have its own edge MANO and its own MEC functional blocks. And then when some client of that CSP wants to deploy some MEC application, it can access the edge MANO and request the instantiation of its MEC application. So with this in mind, we obviously did some progress since last year, and I will now try to provide the main progress that we have done. So probably the main progress was that we now finally have a real edge environment, and well, last year's presentation was mostly based on results that we were having on a cloud setting because we didn't have access to the real edge. But now we are working actually with two factories, and these two factories are the Bysteel factory and the Fapajal factory in Portugal, which have a lot of edge equipment. One of them has a lot of cameras and the other has a lot of sensors. And this equipment produces a lot of data, which in an usual scenario would be sent to cloud somewhere. But since we are trying to research edge technology, we actually have deployed some edge servers in these edge locations to process on-site all of this data being produced. But because of this, we had obviously to adapt our network service that we present to you last year. So last year, we have presented a network service which deployed all that edge environment that I presented previously. So this network service was composed of a Kubernetes cluster launched as a VNF, which was supposed to be the Kubernetes or the edge Kubernetes cluster, where then clients could deploy their MEC applications. And then it would also have a CNF or the Charmed OSM, which was supposed to be the edge OSM, and then also a CNF for the multiple MEC components. But this worked very well for our cloud environment, but now we have multiple points of presence because of this factory. So we have multiple edge servers on multiple edge locations, and therefore we have multiple VIMs, each one for each edge location. And because of that, we needed to make some adaptations to that network service to work in this new environment with multiple edge locations. And because of that, we have divided the Kubernetes cluster VNF into multiple VNFs. So now we have a Kubernetes master VNF, which is deployed in the cloud. And then we have multiple Kubernetes worker VNFs. And each Kubernetes worker VNF will be deployed in each edge location. Then you also might notice that in this network service, we have many more virtual links. And this is because in this new environment, we also have many more networks than before. So first, we have a network which is used only for management. So it's used for OSM to contact the multiple virtual machines to install the necessary Kubernetes software. Then we have a second network which is only used for internal communication between the worker nodes and the master node. And finally, we have a third type of network, which is the factories network. And this network is only connected to the Kubernetes workers. So the second difference that we have now in relation to the last year setup is that we now deploy the day 1 and 2 scripts in a different way. So in OSM, we deploy day 1 and 2 scripts using execution environments, and we have two types. So we have Juju-based execution environments, and we have Elm-based execution environments. And obviously, these are very different technologies, and they have obviously very different characteristics. And the characteristics that we are most interested in were the documentation, and we found out that Juju has some poor documentation in relation to Elm. Then, as far as we can understand, Juju is language dependent, so it can only, or we can only use Python to write Juju charms, while on Elm we could use probably any language. As far as we can create a container which packages a program that we have created in some specific language. Then on OSM, Juju requires, let's call them weird libraries to create Juju charms like the charms.osm, while on Elm we just only have to create some RPC API. And finally, we found Juju to have some performance issues that we didn't like, and we found that Elm just worked most of the times and it didn't have a lot of performance issues, at least in our environment. So with this in mind, we decided to give it a go to Elm charts, and we migrated everything that we have created using Juju to these new execution environments. However, using a new execution environment was not enough because Elm would just launch a bunch of containers, but we needed something to run inside of those containers. And therefore, we decided to use Ansible, and we installed an Ansible controller inside of each container of each execution environment. So we have a bunch of Ansible playbooks that will install all the Kubernetes software in each one of these virtual machines. In each one of these containers, we also have installed a simple Python script that we have created just to translate the OSM primitives to each one of the playbooks that we have created. And finally, I only wanted to present some results that we already have obtained. And these results demonstrate the simple comparison between the deployment of our Edge network service using Elm-based execution environments and Juju-based execution environments. So with an Elm-based installation, we obtained an instantiation time of more or less 6 minutes, while with a Juju-based one, we obtained more or less 10 minutes. So with Juju, we take 65% more time, more or less. So then another different thing since the last year's presentation is that our MEC applications now need to communicate in more than one network. What I mean by this is that well, if you already have used Kubernetes and you have already installed Kubernetes pods, you might have noticed that your Kubernetes pods only have one network interface. And this network interface is attached to the Kubernetes cluster network, and it allows the Kubernetes pod to communicate with other Kubernetes services, sometimes to communicate with the internet, and if you want, you also can create services to, for example, expose some service on your pod to the outside of your cluster. But in our new environment, this wasn't enough because we now have multiple edge equipment in a different network, in the factory's networks, and therefore we needed to find a way of having Kubernetes pods with more than one network interface. And we achieved this by using Multus. So Multus is a Kubernetes CNI which allows us to have multiple CNIs in our Kubernetes cluster. So you can think of it as a CNI of CNIs. And in practical terms, it means that we can create Kubernetes pods with more than one network interface. And with this, our MEC applications now can have two interfaces, and therefore they have the default one, which allows the MEC application to access the Kubernetes network. And then we also have attached a new one, which is bounded to a physical one on the host through IP VLAN. And with this, the MEC application can now easily access the edge equipment on the factory's network. And finally, the last thing that I wanted to present and that we needed to do this here is the usage of a GPU in our edge servers, and therefore the adaptations we needed to do to allow our MEC applications to use a GPU. So, as I already presented some slides ago, there is a factory which has a lot of cameras, and these cameras produce a lot of images. And therefore, the MEC applications which will process those images will benefit a lot if they can access a GPU. So we found that using OpenStack, it was very easy to pass through a GPU from the host to a virtual machine by introducing some new parameters in our flavors metadata, but we didn't find a way of doing this using OSM. So we found this to be a new opportunity to introduce a new feature on OSM, and we have already created a proof of concept of this new feature. So now we can insert on our VNFD some extra specs, which then will be mapped out to the OpenStack metadata of some flavor. And with this, we could pass now the PCI pass-through of a GPU, and we were able to create virtual machines which have access to the edge server's GPU. And well, this was everything that I had to present you today, and I hope that you like this session. So thank you.